All right, so for today's lesson, what we're going to do is talk about inscribed angles. And basically, an inscribed angle is an angle whose vertex happens to be on the circle. So we talked about central angles the other day, and those vertices were actually the center of the circle. So now for an inscribed angle, the vertex B is on the circle, as are the endpoints of the angle. So angle ABC happens to be an inscribed angle. Now, the measure of the inscribed angle has a relationship with the arc it sits in. So we still have inscribed angle ABC, and if you take a look at the arc that's in between the two sides, that arc happens to be from A to C. We call that arc the intercepted arc. Well, we're going to take a look at what happens with the angles of the inscribed angles and the measures of their arcs. So let's come down here. If you take a look right now, you've got inscribed angle ABC. It sits inside arc AC. Right now, if we just look at the whole numbers, the measure of the angle 70 and the measure of the angle 140. Well, what's the relationship? 70 is half of 140, or 140 is double 70. As you move this angle around, and we were to round 49, let's say, to 50 degrees, and the measure of this arc 99 to 100, then the measure of the inscribed angle now, ABC, 50, is still half of its arc. So it does not matter how you move around or manipulate this particular angle, but 77 degrees, we're rounding angle ABC inscribed in arc AC, which is also 154. So arcs are double their inscribed angles, or inscribed angles are half of their arcs. So let's get rid of this. Let's go back here. So that's what we're going to fill in on the notes. I keep having to go from the smartboard to the computer, but the measure of an inscribed angle equals half the measure of its, we call the word intercepted arc. It's just the arc that it sits in. So for example, we could say that angle ABC equals 1/2 of arc AC, or we could say twice the measure of angle ABC equals the entire arc of AC. Okay, so then we take a look at the next one. The word inscribed should always make you think of half. Semicircle, hopefully you realize, is 180 degrees. Well, this should be pretty intuitive. If you're an angle inscribed in a semicircle, if you are 1/2 of 180, then you're always going to be 90 degrees. We'll take a quick look at that. And here we go. So right now, angle BAE, inscribed in semicircle BAE, is 90 degrees. I want to make this circle a little bit bigger for a second. I think that's this one. Nope, maybe not. All right, there we go. If I start now moving this angle A anywhere inside this top half or bottom half of the circle, my measure of the angle BAE is still 90. Doesn't matter. This is never changing. I could even make the semicircle on the other side. Now I'm in the top half of the circle, but the inscribed angles are always going to be equal to 90. It doesn't change. So what's happening here then is the measure of angle ABC is 90 degrees. The measure of angle ADC is 90 degrees. The measure of angle AEC is 90 degrees. Inscribed angles that intercept, that sit in the same arc. Well, think about that. If I outline this angle DAE, and I'm going to go a little bit further, if I outline angle DAE and I outline angle DBE and I outline angle DCE, hopefully you realize that all of those angles sit inside this one arc. That should tell you that angles inscribed in the same arc have to be equal, have to be congruent. So we'll do a quick look at this. And we see that, let me move this for a second. So this arc CD happens to be right here. This arc happens to be 53 and change. Well, look at the angles. This red angle CED is 26.66. Let's actually do some rounding over here. We're going to call this thing 27. We're going to call this thing 54. But this angle CED is half of arc CD. This angle that's dotted CFD is the same as the what's in red, and the angle CBD, the angle blue, is the same as the other two. They're all half of the arc they sit in. Okay?